In this video, we will see about the characteristics of DC generator. What is a DC generator? A DC generator is a machine that converts mechanical energy into electrical energy. We know generator means it gives electrical output. It is based on the principle of Faraday's law of electromagnetic induction. So whenever a flux is cut by a conductor, EMF is induced in the circuit. Let us see the important characteristics of DC generator. So first is the open circuit characteristics, normally written as OCC. It is also called no load characteristics or magnetization characteristics. And then we have internal characteristics and external characteristics. These three characteristics are important for a DC generator. Already we have seen that there are different types of DC generators. One of them is separately excited DC generator. So we know in separately excited generator, the field winding is given a separate DC power supply. So this is a DC separately excited generator. So we will see about the open circuit characteristics, which is between the generated EMF versus this field current. Actually, we are varying the field current and we are observing what is the voltage generator. And then we have to find the internal characteristics. This is with load we are finding. So you have armature current here. Same characteristics, but this is by varying the field current. Internal characteristics means you are varying the load current and finding the generated EMF. External characteristics means you have the terminal voltage V. This V and load current, you are finding the characteristics. So one is with respect to this generated EMF versus load. The other one is terminal voltage and load. First, let us see about the open circuit characteristics, which is also called OCC or no load characteristics. So no load characteristics means the generator is not loaded. The terminals are kept open. Now you are varying the field current and finding what is the generated EMF. So you keep on changing the field current and see what is the generated EMF. So that is called no load characteristics. So you have to remember at that time the speed should be maintained constant. This no load characteristics actually helps to study the performance of the machine under different levels of field current, because you are varying the field current and studying how your machine works. It is also helpful to study the saturation characteristics of the machine. It means that whether if you give the field current beyond a limit, the poles will get saturated or not, because you cannot run the machine at any speed, or you should know what is the range of speed or range at which you can work with the machine. So for that, this saturation characteristics of the machine will help, because beyond a field excitation, the poles may get saturated. Practically, this OCC characteristics will be same for, that is, the shape will be same for both separately excited and self-excited machines. Now let us do this experiment to find the open circuit characteristics. See here, the load is removed, only armature is connected across the voltmeter, and here you have a field rheostat to vary the field current. First, make sure your generator is running at a constant speed. Then whatever you vary the field, you will get the voltage here. for various field current you will get various voltage, terminal voltage. You mark that. That will be the OCC characteristics. Now the generated EMF is given by 5Zn by 60 into P by A. This equation we have already derived in the previous video. So Eg is equal to, Eg is directly proportional to flux into speed. Here we have kept the speed constant. So Eg is directly proportional to flux. Flux is nothing but field current, because field current will decide the flux. So Eg is directly proportional to field current. Now we are drawing between this generated EMF and the field current. So the characteristics, actually it should be a linear one, but we are getting a characteristics like this. So if you see here, when the field current is 0, there is some voltage, OA is the voltage. So what is this? How we are getting a voltage even at 0 field current? This is due to residual magnetism. That is, before giving the field current itself, in the poles there will be some voltage will be there. That is due to the previous magnetization effect, there is some voltage. So that is the generated EMF at 0 field current, or this is the voltage due to residual magnetism. Then after that you will get almost a linear characteristics for some time, and when the field current is increased beyond a certain point, this linearity will go, because after that, that is, if you see in this CD section, the poles get saturated. So though you increase the field current, there will be no major change in the generated EMF. So this OCC characteristics helps to find the range under which you can operate the machine. So at low values of field current, this EMF increases linearly, and after some time the poles saturate and Eg rises slowly. Now let us see the internal and external characteristics. So this is drawn between the EMF as well as load current. So this is actually load characteristics. We are loading the machine and observing the performance. So as you load the machine, the generator should produce constant voltage. So if it produces constant voltage, we call it as ideal characteristics, because practically that is not possible. As you load the generator, the voltage will drop. So if there will be drop due to two factors. One is the drop due to armature reaction. So if you consider that drop, so you will get one characteristics, that is called the internal characteristics, which is drawn between the generated EMF as well as load current or armature current. But there is also another drop due to armature resistance. We know in armature there will be a resistance RA, and I into R will drop. So due to that, one voltage drop will occur. So if you draw the plot between the terminal voltage and the load current, we call it as a external characteristics. So this is internal. If you consider only armature reaction, it is internal, because we cannot see what actually happens. So that is internal. External characteristics, it is drawn for the outer terminal voltage, so it is called external characteristics. Now let us see what do you mean by this armature reaction. We have main field poles which will generate a magnetic field. Similarly, the armature, which is rotating inside, has a current carrying conductors. So this current carrying conductor will also set up a magnetic field. So the effect of this field on the main field is called the armature reaction. you have two magnetic fields. One is set up by the poles, the another one is set up by the armature conductors. Due to this armature field, the main pole field is getting distorted. This is called armature reaction. So what is the net effect of this armature reaction is that the induced EMF, the generated EMF will be reduced as the load increases. Next we will see about self-excited generator. So in that we know there are three types: shunt generator, series generator and compound generator. First we will see about shunt generator. So shunt means field winding is connected in parallel across the armature. The difference between separately excited and self-excited is that in separately excited, field winding is given a separate DC supply, so you can easily vary the field current. Whereas here the armature is connected in parallel to the field winding and the armature supplies the field winding also. So here also we will see about open circuit characteristics, internal characteristics and external characteristics. The OCC characteristics of shunt generator is similar to separately excited generator. Here also when the field current is 0, due to residual magnetism there will be some voltage. When you increase the field current, EMF also increases. After a certain point, the poles get saturated and any increase in field current will not increase the generated EMF to a very high value. Let us see what is this critical resistance. First, we have already drawn the OCC characteristics, that is the graph AB. Now draw a tangent to this OCC characteristics. That will give you the value of critical resistance. That is the slope of this line. Y-axis you have voltage and in x-axis you have current, field current. So you take y by x, you will get the resistance value, that is called critical resistance. Why it is called critical resistance means if you increase the resistance, that is if your field resistance is somewhere here or greater than the critical resistance, the machine will not build up its voltage because it is a self-excited generator. It is not separately excited generator. Self-excited means the machine has to supply the field current. So the resistance should be less than the critical field resistance so that the generator can build up its voltage. Now, in self-excited generator, you have three conditions to be met for the machine to build up the voltage. First thing, there should be some initial residual magnetism. Only if it is there, the machine will start to increase its voltage. Otherwise, the machine cannot build voltage. So, some residual magnetism should be there. And the field coil should be properly connected. It means that if you connect the field coils in opposite direction, this residual magnetism may get cancelled and it becomes zero. So, the field coil should be connected properly. Then the field resistance should be less than the critical resistance. If the field resistance is more, the machine cannot excite. Now we will see the internal and external characteristics. Ideally, as you increase the load is nothing but armature current. As you increase the load current, the voltage should remain constant. But practically it will not be constant and it decreases due to various reasons. So we know in a shunt generator IA is equal to IL plus ISH. So if you increase the load, what happens? IL increases, it means that IA also increases. So if IA increases, IARA drop, because armature resistance is a fixed one and you have this IARA drop will increase. So what is the terminal voltage? V is equal to EG minus IARA. So this part increases, so voltage decreases. So this graph is drawn between the terminal voltage versus armature current. So here the drop due to armature reaction is taken into account. Here the drop due to armature resistance is taken into account. So the graph between E and IA is called external characteristics, and the graph drawn between the voltage, terminal voltage and armature current is called external characteristics. Next, let us see about the DC series generator. So the important thing to be noted here is that the armature, field winding and the load are connected in series. So all the currents are same. IA is equal to IL is equal to field current IF. So if you want to do OCC characteristics, if you keep the load side open, this field and armature will be open. So you have to take the OCC characteristics like a DC, separately excited DC generator. That is, remove the field winding and connect it to a external DC supply and take the OCC characteristics. Here you have to note that always DC generator should be connected to some load, and the resistance of the load or the total circuit resistance including the field resistance and load resistance, that should be less than the critical resistance, so that the EMF will be developed. So the armature current is IA is equal to IL equal to ISC, and EG is given by V plus IA into RA plus RSC. Next we will see the internal and external characteristics of DC series generator. Here the field current and the load current are same. They are connected in series. So as you increase the load or increase the field current, what happens? EMF will increase. So now here if you are increasing the load, the voltage generated will also increase. So this is a peculiar property of a series generator, where as the load increases, the EMF also increases. But this internal characteristics is drawn between the generated EMF and load current. So by considering the drop due to armature reaction. External characteristics, as usual, you have to consider the armature resistance drop as well as series field winding drop. Both drop, if you subtract, you will get the terminal voltage, and the curve between terminal voltage and load current will give you the external characteristics. Next we will see about DC compound generator. So we know there is a shunt field as well as a series field in compound generator, and there are two types of compounding: cumulative compounding and differential compounding. If both the flux due to shunt field and series field aid each other, it is called cumulative compounding, and in differential compounding they oppose each other. So it has very few restricted application. So we will see about cumulative compounding. So here the level of compounding can be changed by changing the amount of current passing through the field. Depending upon the level of compounding, we have three types: over compounding, flat compounding and under compounding. So here you see a dotted line is drawn, okay, and here one dotted line is there. So this V represents the no load voltage, that is when the load current is 0, you have a voltage of V, and this dotted line represents the full load voltage. Okay. Now you see in over compounding, the full load terminal voltage, that is this point, is greater than the no load voltage. So it is said to be over compounding. In flat compounding, this no load voltage as well as full load voltage are same. Though it increases here, after that it decreases, and at full load it is equal to this no load voltage. So in that case it is called flat compounding. And in case of under compounding, you can see this full load voltage is less than the no load voltage. So let us see the applications of DC generator. So separately excited generator, they are able to produce a wide range of voltage output. So they can be used in laboratory and commercial testing, and for speed regulation test. And DC shunt generators, they can produce a constant terminal voltage. So mostly they are preferred for excitation of alternators and to charge the batteries. And if you take a DC generator, it is mainly used as voltage boosters, because with increase in load it can give you a increase in voltage. And it is also used in series arc lighting. Next we have a differential compound generator. Mainly, or its only application is arc welding generator. And if you take cumulative compound generator, it is used for various purpose, for supplying power to DC motors, elevators, in railways, everything. You can find cumulative compound generator. So the points to remember here are, in DC generator, 3 points are important, or 3 characteristics are important. One is the open circuit characteristics or no load characteristics, and then internal characteristics, and then external characteristics. And the armature reaction means the effect of the magnetic field set up by the armature current on the main flux is called armature reaction. What is the effect of armature reaction? It demagnetizes the main pole flux, and it also distorts the main flux. So due to this, the EMF induced will decrease as the load increases. So the conditions for build-up of a self-excited generator is that there must be some residual magnetism, so that the machine can build the EMF, and for given direction of rotation, the field coil should be properly connected to the armature terminal. Otherwise, residual magnetism will become zero. And this shunt field resistance should be less than the critical field resistance. If you like the video, do subscribe to Read Electric Vehicle channel. Thank you.